is Adrian May, and I hope you've been following my series of math videos for the SAT and the ACT. This video we're going to revise a few basic exponent rules, and what we're going to look at here is multiplying and dividing exponential expressions with the same base, raising powers to other powers, and eventually comparing two exponential expressions with different bases. Now we're going to do this with an aim to answering just one question. This question here from the SAT, which is one of my favourite SAT questions, because it's often when people look at it, they get stuck. They don't know how to approach it. It's one of these classically oblique SAT questions where we have two expressions and it's not entirely clear at first how they relate to each other. So by revising some exponent rules, we're going to see how questions like this, once we know what we're doing, they just solve themselves in their entirety really quickly, and in a way that I find quite aesthetically pleasing and quite satisfying how quickly the solution arrives. The next exponent video I'm going to do, we're going to look at fractional exponents, which is a very trendy topic right now, and we're going to end that one by looking at one of the most unpleasant looking ACT questions there has been today. So both videos are useful for both the SAT and the ACT. This one's going to end with an SAT specific focus. The next one will end with an ACT specific focus, but you should be watching both because especially fractional exponents is a very trendy topic in both sets of exams right now. Okay, so if you're ready to start our revision of exponent rules, we're going to get right to it right now. So, to begin our revision session of exponent rules, the first thing we need to remember how to do is how to multiply together exponential expressions that have the same base. And by base, we mean these numbers down here, the bottom of the expression. So here we're multiplying 2 to the power 3 by 2 to the power 4. Both of these have a base of 2, and therefore we can use this exponent rule in this case. So when we multiply 2 to the 3 by 2 to the power 4, we add the exponents together. So this gives us 2 to the power 3 plus 4, which is 2 to the power 7. And one thing that's useful to think about is if we forget how these exponent rules work, you think about what this actually means. What is 2 to the power 3? Well, that's going to be 2 multiplied by itself 3 times, whereas 2 to the power 4 is 2 times 2 times 2 times 2. And if we multiply these together, we have 1, 2, 3, 4, 5, 6, 7 2s. And so this is 2 to the power 7, which is 3 plus 4. So just to look at one or two other examples, we could have, say, 7 to the power 4 multiplied by 7 to the power 6. And what would this give us? This would give us 7 to the power 4 plus 6, which is 7 to the power 10. And the same thing happens with algebra. It works in exactly the same way. So we could have x to the power 15 multiply x by x to the power 17. And again, what would this give us? This would be x to the power 15 plus 17, which would be x to the power 32. Okay, so if that's making sense, we're going to move on to the next thing, which is dividing exponential expressions that have the same base. And if multiplying, we added the exponents, when we're dividing, we're going to subtract one exponent from the other. And so this is an example here. We have 2 to the power 7 divided by 2 to the 4. Again, we have the same base. We have 2 at the bottom of both expressions. And this time we're going to go 2 to the power 7 minus 4, which gives us 2 to the power 3. And again, if we need to check in an exam, if we forget how these rules work and we want to make sure we're doing this correctly, we think about what this means. 2 to the power 7 is 2 multiplied by itself 7 times. 2 to the power 4 is 4 lots of 2. And if we stack these one on top of the other, we can cancel out 4 of these 2's, and we're just left with 2 times 2 times 2, which is 2 to the power 3. So again, let's work through one or two examples so you can get a sense of how this works. If we had 5 to the power 10 divided by 5 to the power 8, this would give us 5 to the power 10 minus 8, which is 5 to the power 2. And again, we can make these as big as we want. That's the use of exponent rules, is you can use some very large numbers and this still works out in the same way. So let's have, I don't know, x to the power 100 divided by x to the power 94. And this is going to give us, again, what will this give us? It'll be x to the power 100 minus 94, which is x to the power 6. Okay, so that's the first two rules we need to know, how to multiply and divide like bases. And now we're going to go to the last thing we need to revise, which is raising powers to other powers. And so again, to remember how to raise powers to other powers, we have this example. We have 2 to the power 4 raised to the power 3. And here we're raising 2 to the power 4 to the power 3, and we will multiply the exponents together. So this gives us 2 to the power 4 times 3, which is 2 to the power 12. And again, if you want to think about why this makes sense, what is 2 to the power 4? That is 2 times 2 times 2 times 2. But when we're raising it to the third power, we want 3 lots of this. So if we stack this up, we have another 2 lots of 2 to the power 4. And when we add all of these together, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lots of 2. So we had 4 lots of 2. We multiplied that by itself 3 times. We have 2 to the power 12. So to give you, again, 2 more examples, we could have 7 to the power 10 raised to the third power, and that would give us, what would that give us? It's going to be 7 to the power 10 times 3, which is 7 to the 30. And again, with algebra, in exactly the same way, we could have x to the power 6 raised to the 6th power, and this again is going to be x to the power 6 times 6, which is x to the 36. Okay, so they're the 3 rules we needed to know how to revise, and next we'll go on to how to compare exponents with different bases. So this is a revision of a few of the brief rules of exponents that are important for this question. What we need to think about next is how to compare expressions that have different bases. We've dealt with how to add and subtract expressions with the same base, how to raise powers to other powers, but now we need to compare unlike bases. And so in this first question, we have 3 to the power 8 equals 9 to the power x. And there is a way of figuring out what x is, but currently our exponential expressions have different bases. We have a base of 3 and a base of 9, and so we can't yet deploy our exponent rules to solve this question. So what you usually want to do when you have different bases is to take your highest base, in this case 9, and try and rewrite it in terms of the other base, which is 3. And so we want to rewrite 9 as 3 raised to a certain power. And 9 is 3 squared. So 9 is equivalent to 3 to the power 2. And so we can substitute in 3 squared for 9 into our original question. And so we get 3 to the power 8 is equal to 3 squared raised to the power x. And now we can use our exponent rules to answer the question. We know that 3 squared raised to the power x is 3 to the 2 times x, or 3 to the 2x. So we have 3 to the power 8 equals 3 to the 2x. Now we have the same base on the left and right hand side, we can compare the exponents together. And so we know now know that 8 is the same as 2x, and therefore we can just divide by 2 and we get 4 equals x, or x equals 4. So by rewriting expressions with the same base, we've been able to solve this question. So let's run through 1 or 2 more of these because this is super important for the SAT and the question that we're going to come to look at. So, for example, we could have 125 to the power 3 is equal to 5 to the power y. And again, in this case, we want to take our highest base, 125, and rewrite it in terms of 5. So 125 is 5 raised to what power? Well, 5 times 5 is 25, times by 5 again is 125. So 125 is 5 to the power 3. So again, we substitute 5 to the 3 in for 125 in our original question, and we get 5 to the power 3 raised to the power 3 equals 5 to the y, and therefore we multiply 3 and 3 together to get 5 to the power 9 equals 5 to the y. And now we know that we have the same base, we can compare the exponents on the left and right hand side, and we know that y is now equal to 9. Lastly, we could have, 2 to the power 40 equal to 16 to the power z. So once more, the numbers look bigger, but it's the same process. Let's start with 16 and rewrite it in terms of 2. So 2 times 2 is 4, times 2 is 8, and times 2 again is 16. So 16 is equivalent to 2 to the power 4. So we substitute that in for 16 in our question, and we get 2 to the power 40 is equal to 2 to the power 4 raised to the power z. Now again, we can use exponent rules to multiply 4 and z together. So 2 to the 40 is the same as 2 to the 4z. And now again, our bases are the same. We can compare the left and right hand side, and so we know that 40 equals 4z, and therefore if we divide by 4, we get 10 equals z. And we've solved that question. This has given us all the tools we need to answer the SAT question we started with. We're going to bring that back on screen. I'm going to let you have a look at it, see if you can solve it yourself, and then we're going to talk through how we got to the answer. So, here is the question. If you want to pause the video and have a go at it yourself, given what you've learned, please do so. And my suggestion would be to start with the exponential expressions. Okay, how did that go? Now, as I said, the mistake most people make is they often want to start with this 3x minus y equals 12 bit, because we can rearrange that quite easily if we wanted to. We could say 3x equals 12 plus y, divide by 3, and so x equals 12 plus y over 3, and so on. But that doesn't get you very far. So one thing I would want to think of is our answer choices all seem to have exponents in, other than the last one. And then we also have this exponential expression to the right-hand side, and we might notice immediately that we have different bases. And so given that our answer choices are all exponential expressions, we have this phrase here, it seems very much like this is an exponent-based question, and so it makes sense that that's where we would want to start. And so what we do here is we realize, again, we have unlike bases, so we're going to have to change that. So we need to think about 8, the higher base. And so 8 is the same as 2 to what power? 2 times 2 times 2 is 8, so 8 is 2 to the power 3. So again, we can substitute that into our original questions. So we have 2 to the power 3 raised to the power x over 2 to the power y. Now we can start deploying our exponent rules that we've been doing all the way through. So we need to multiply that 3 and the x together. So we have 2 to the 3x over 2 to the y. And when we divide exponential expressions with like bases, we subtract the exponents from each other. So this becomes 2 to the 3x minus y. And again, some students get to that point and they're like, great, so I figured that out. Now what do I do? Well, now we go back to the question itself, and then we realize that we're already given a definition of 3x minus y. 3x minus y is the same as 12. And so our answer simply becomes 2 to the power 12, which is answer choice A. And so I hope you get a sense of how quickly that question solves itself once we figure out what to do. It may seem obvious now we built our way up to that question, but if we weren't so confident about exponent rules, we didn't identify it was that type of question, and we didn't start changing the bases as the very first step we did, people can get lost very, very quickly with that question. But when you do solve it, it actually becomes quite a neat and satisfying solution. So if you got that yourself, good job. And if not, hopefully this has helped kind of give you a sense of how to approach SAT questions like this. Okay, so I hope that was a useful revision of one part of exponent rules. As I said, the next video I do on exponent rules will deal with fractional exponents, which again, I hope you stay tuned for. I think that's sometimes questions look very complex, look very ugly, but actually they're not so bad once you know what you're doing, so look out for that video. Please do like and subscribe to the channel if you're finding these useful. Any questions or comments you want to leave them, please leave them below. And if you need any further help with the ACT and SAT, please do get in touch. I'm a tutor. I do give one-to-one lessons to help people out, either in person in London or in Glasgow, or online, so I can help you wherever in the world you are. So if that sounds like something you want, please do get in touch. My website is also below. From there you can get in touch with me and organise lessons in any kind of form you would like. Otherwise, again, please do like and subscribe, please do leave comments, and hopefully see you all soon. Have a good day.